Hello everyone, we are Group 1. Today we will present electronic field light of the charge bisector. In example 2.3, electronic field on the perpendicular bisector. We consider a non-conducting rod of length with a uniform charge density lambda and a total charge is layered along the x-axis. To find the electronic field at a point located at a distance from the center of the rod alone is a perpendicular bisector. So, this equation gives the y component of the electronic field on the perpendicular bisector of the uniformly charged rod. E sub y equal 1 over 2 pi absolute naught time lambda over y time L over 2 or divided by the square root of y squared plus L over 2 squares.
So I will be explaining how we created this HTML application. Firstly, we made a few initial prompts to the AI by showing it how the electric field should look like in these slides, and then asking it to calculate the electric field for different cases with variable relevant and symbol for each cases. The variable need to be able to change using the sliders, as well as a formula for the electric field in each case, and then the electric field lines to show the visualization of the electric field, as well as the gradient for the electric field strength, and it should be in 3D. And after making a few adjustments, we are centered on the line charge bisector, which is shown here. And other than the initial prompt, we also made a few improvements, such as the showing of the situation, the improved version of the formula, as well as the derived total charge and the final electric field calculation. And there is also the graph. And other than the graph, there's also the test charge, which can show us how the proton and electron react to this electric field.
Okay, so I will describe about the application of this HTML file. So as you can see, we can vary the linear charge density lambda at here. So you will see the arrow is pointing up, show the electric field, and pointing out means that the positive charge in the rod, and also we have the negative charge, then the arrow will be pointing into the rod. Okay, so you also can change the rod length L at here. So you will see the electric field line, how the electric field stimulation, and also the distance. Okay, so this one is the distance y at different meter. Okay, so you can see the electric field value at here. So this value is already verified. It is correct answer according to this electric field formula for the rod. And you can also check the graph at here. Okay, so you can move it to check how the electric field is changing, and also this one. So we have two graphs. One is the E versus Y. Another is the ratio of EY over E0 versus Y over L. So we also have the H charge at here. So you can put a proton. So you can put the proton. So then you can see how the proton or electron is moving under this electric field.
Okay, to conclude our presentation, this assignment successfully merged the theoretical physics with the modern technology. The core principle we demonstrate is the calculation of the electric field on the perpendicular bisector of a charged root, which utilize the integration and symmetric arguments. Specifically, we learn how the principle of the superposition combined with the geometric symmetry, and we simplify a complex integral into the final concise formula. More importantly, we gain the variable experience using the AI tools like Gemini to generate the functional HTML coding for a physics problem, returning a static formula into a dynamic interactive simulator. This experience will be invaluable in our future study. We now have the foundation to create the interactive learning tools, helping us to visualize the complex phenomena. The ability to model and visualize the data is a crucial skill for any modern physicist or engineer, and this project was an excellent step in that direction. Thank you.